pues es todo un lujo contar con el director de Google Research, el centro específico sobre inteligencia artificial, que está en Zurich, Emmanuel Mogenet, que ya está por aquí, nos va a dar la visión que tiene Google sobre todo lo que está pasando en inteligencia artificial y machine learning. Pues, Emmanuel, cuando quieras, un aplauso fuerte para él.
Hello, everyone. My name is Emmanuel Mogenet. I work for Google, and my passion is artificial intelligence and, in particular, machine learning. So thank you very much for having me here today. I will take 20 minutes of your time to try to explain a little bit what machine learning is, and maybe a little bit how it works, to try to get you to understand the possibilities that this will bring to society. Okay, so very briefly, this is where I work. I have a lab in Zurich where we are trying to advance the state of the art in machine learning. Specifically, we work on trying to get computer to understand human language, what we call natural language understanding. We're trying to get computers to try to understand the world that they are looking at, so it's called computer vision or computer perception. And we're also trying to advance the state of the art in artificial intelligence, specifically doing deep learning research. And there's about 150 of us, with the bulk of the researchers in Zurich, then the rest in London and Paris. Okay, you probably know this or have heard it before, but Google's mission is to organize the world's information and make it universally accessible and useful. This is not exactly something new. We've been trying to do this for 20 years. The problem, unfortunately, has grown much bigger. When we started, the internet was small, trying to figure out what was out there and help people find information in it was a relatively easy, quote-unquote, problem. But the internet has exploded. Information is now not just textual, it's videos, it's sound, it's everything. And trying to get people to find useful information on the internet has become a much bigger problem. We believe that the only way we're going to be able to tackle this problem as the internet explodes is to use machine learning. So this is our CEO, Sundar Pichai, and Google had to historically undergo a revolution when the mobile phone came about, where we used to be a search company that you would access via your desktop computer, but suddenly the cell phones came about, the digital PDAs, whatever you want to call them, and we had to completely rethink our business model. It was a revolution, and the company had to transform itself. We're now doing it again. We believe that machine learning is going to so deeply transform the world of the internet and our business that we need to basically make a 180-degree turn as a company. So we are starting to basically use machine learning everywhere at Google, but I'm going to give you a few examples. We're using to do automatic translation. We use it, when you speak to your phone, speech recognition, converting speech to text. We use it whenever you watch YouTube videos. We sort of do a recommendation on what to watch next. This is using machine learning. We use it to understand what happens in your photographs, like all the pictures that you take with your phone. We can actually try to understand what's happening in there to help you find them and classify them. We can do time series prediction, and of course, if you think about it, Google's core business since day one has been understanding human language. People come to Google, they ask questions, and if we want to answer those questions properly, it's a lot better if we actually understand the questions. So these are, not going to dive into it, but these are all the products where we are already using machine learning. We're using it in Gmail to filter spam. We're using it in search to return better search results. We're using it Google Play and YouTube for recommendation. We're using it for Translate. Translate is actually 100% machine learning. We're using it Google Photos, etc., etc. Okay, so this is the part where I try to get you to actually understand what machine learning is and why everyone's so excited about it these days. So a little bit about vocabulary first. Everyone's talking about artificial intelligence. Artificial intelligence is a very old discipline, and machine learning is a sub-discipline of artificial intelligence. There's many techniques to do artificial intelligence. Machine learning is one of them. Deep learning, which you probably have heard as well about, is a subset of machine learning. And specifically, it's a subset of machine learning that tries to mimic, to imitate the way the human brain operates, right? And the reason when everyone's speaking about artificial intelligence these days is specifically because the yellow thing there in the middle, around 2004 and 2006, started to really work well and deliver results. So this has, generated sort of a rebirth of the topic. But please understand that, what's really new in machine learning or in artificial intelligence in the last decade is truly deep learning. Again, AI is not new, right? From the day we started to build computers, we tried to teach them to do useful things. In other words, we tried to teach them to do things that we humans do. So artificial intelligence has been a goal from day one when we had computer, except it never worked. Up until like very recently, all the attempts at doing fairly smart things with computer failed. Translation, for example, is a perfect example. We've been trying to do automatic translation with computers since day one, and it only started to work around 2006, 2007. The other thing people have a tendency to commingle is artificial intelligence and robotics. Robots might very well benefit from artificial intelligence at some point, but currently the bulk of artificial intelligence is just algorithms running on the internet, typically, right? There's actually very few robots today that have the kind of techniques we're going to talk about today built into them. Okay, so why is everyone excited about machine learning? Very briefly, up until very recently, the only way you could teach a computer how to do something useful. This is really all it is about, right? Teaching computers about to do something useful. The only way you had to do this was to program them, right? To write a program. And a program, you can, for those of you who've never had to do this, you can think of a computer program as a cooking recipe. It's just a list of instructions that you have to follow one by one in order to execute something useful. The perfect example is you've all learned at school to multiply numbers, right? And the teacher just gave you a recipe and you applied it without necessarily understanding what was really going on. You just followed the steps, right? Programming computers up until recently was exactly like this. The problem, there's a lot of things we do as humans that cannot be explained that way, right? For example, look at me. I'm walking, right? It's something I do without thinking. If I had to explain to you guys how I'm walking, how every muscle in my body moves as I walk, I'm incapable of doing this. Or a simpler task, if I show you a picture and ask you, is there a cat in this picture? You know immediately how to answer, but if I ask you to explain how you do it, you can't do this, right? All these tasks that we humans perform effortlessly and intuitively, but we can't really explain how we get to the result, we couldn't teach them to computers. The magic of machine learning is we now can program computers to do these things. Well, actually, we don't program them. We show to the computer enough examples of us performing the task, and they eventually learn to perform the task themselves. So the archetypical example, to get you to understand how this works, is the cat and dog picture. So the task is teach a computer to discriminate between a cat and a dog. I show a picture to the computer, and the computer has to guess, is it a cat, is it a dog? Up until 10 years ago, we couldn't do this. We had no recipe to explain to a computer what a cat is and what a dog is. What we do now is we take millions and millions of pictures, some of which contain cats, some of which contain dogs. And with each of these pictures, we have the, if you will, the question, which is the picture itself, and the answer. So we show to the computer, here's a picture of a cat, here's a picture of a dog, here's a picture of a cat, here's a picture of a dog, right? Every time we show sort of the question, the problem, and the solution. And then once we've shown enough of these things to the computer, we ask it, okay, here's a picture, is it a cat or is it a dog? And if it answers properly, we sort of reward it, quote unquote. And if it gets it wrong, we sort of punish it a little bit. So it's the carrot and stick algorithm, right? And if you read, every time the computer makes a tiny, tiny improvement. But if you do this millions and millions and millions of times, the first thing that happens is the computer starts to remember what's called the training set, meaning it remembers the pictures that you've shown it, right? So if you show it the picture, it's going to say, I've seen this picture before, and you've told me that's a dog. And therefore, it gets the right answer. But the magic moment is something called generalization, where the computer, when shown a picture it has never seen before, gets it right. Right? And it takes a lot of computing power, and it takes showing massive amounts of picture. For those of you who are worried that you're going to get replaced by a computer someday, please understand that a human needs, on the average, 3 or 4 pictures to learn to differentiate cats and dogs, whereas computers need to see millions, if not hundreds of millions of pictures to reach the same level of accuracy. Right? But the magic is we have taught the computer how to separate dogs from cats without having to explain anything, right? So now, all these things that we do, that we can't really explain how we do them, can now be taught to computers. This, you're gonna hear a lot about AI, about machine learning. This, what I just described, is at the core of the revolution. Okay, how does this work? I mentioned earlier that deep learning got inspiration from the way the human brain operates. So basically, what you see here is we present, so the human brain is basically a network of neurons. It's like lots and lots of little processing units connected to one another. And what happens is you present a picture, the first layer is going to do very, very stupid things with the picture. It's going to spot like edges, corners, maybe it's going to spot what a hair is. The next layer is going to assemble these ideas, these concepts into somewhat higher concept. So you start at the beginning, you're going to spot an eye, the tip of an ear, some hair, and then the next layer is going to be, that's an eye, that's a mustache, that's a tooth, that's a mouth. And then the next layer is going to say, okay, that's a cat or that's a dog, right? So what you see is the information traveling through the neural network from the left to the right, and at every step, we're climbing the semantic ladder, right? On the left, we do very, very dumb things that we convert into slightly less dumb things, and all the way to what comes out to the end, which is essentially cat or dog, very high-level semantic information. All right. This is also interesting. When you build machine learning system, there's 2 phases. One is training. We essentially teach the system. And once it has learned, you put it in production. You put it to work, just like you would, an employee. There's a training phase, and then once the employee is trained, you actually get him to do things. And the second phase is called testing or inference, is where you have a trained system and you get it to do useful things for you. Okay, here's an example of what we can achieve today. You start from a picture, and your training set here was massive amounts of picture. We're in the order of billions of picture, right? 1 followed by 9 zeros. And for each of these pictures, we happen to have a textual description, typically created by human. So that's our training set. A picture, a textual description. We feed this to the machine, and it typically takes like on the order of like a month to train the machine learning system. But eventually, it knows how to jump from the picture to the text. And the magic is, this picture is a picture that was not part of the training set. It's never seen this before. You feed it to the computer, and out the other end comes a person on the beach flying a kite. So you can essentially create text caption from picture using a machine learning system. Okay, so this is to give you an overview, but I mean, I use the example of pictures a lot, but the framework is anywhere in your business, in your work, even in your daily life, where you have enough labeled data, meaning a set of questions with known answers that you can present to a computer, you can train a machine learning model to essentially go from the question to the answer, even on examples it's never seen. And the framework is very powerful. So where do we use this in our products at Google? Turns out everywhere. We essentially have asked our engineers to massively switch to using machine learning. This is the curve of adoption of machine learning type technique in our internal source code repository. I mentioned this earlier. All of these products are currently either using machine learning or fully based on machine learning. Translate, for example, in photos, the core feature are essentially powered by machine learning. Here's an example of a combination of multiple stages machine learning system. The first one is optical character recognition. So we start from a photo, and we find the text in there. And that's the first machine learning system that has learned to spot where text is in a photo. Then there's a second machine learning system that it has text in one language, jumps to another language. So it's the translate system, which has also learned by example. We just showed it enough example of here's the French sentence, here's the Spanish sentence, here's the French sentence, here's the Spanish sentence. And after showing billions of those example pairs to it, it now knows how to jump from French to Spanish. So the second stage is translation, and then the third stage is taking the translated word and then reintegrating it into the original image. That's all, again, done with machine learning. So it's a combination of 3 different machine learning systems working together. One of our most flamboyant successes with machine learning to date is Translate. We used to have a very complicated hand-engineered machine learning, translation system. It was a very, very complicated cooking recipe, if you will, that was programmed by people and didn't work at all. We threw the whole thing out the window, replaced it by neural networks. So it's one giant neural network. You pump Spanish characters in one end, it regurgitates Japanese characters on the end. We're not exactly sure what it does in the middle. That's the funny part. But it seems to have learned like some sort of Esperanto, actually, because it can now take any kind of language on the input and produce any kind of language on the output. The key things is we have reached almost human quality level translation for the main languages on the planet. Google Photos. Is there a doubt in the, in the audience? Google Photos is another example where people take a lot of pictures. I have some the order of 40, 60,000 pictures on my phone. There's no way you can sort through this. And now I can say, to Google, show me pictures of my son. And it's going to sort all the pictures of my son from my photos. Or you can say, show me pictures of my vacation. And the way this works is all the photos that you take, Google feeds them to a machine learning system that creates text annotations. So if you take a picture like this one, Google's going to say there's a beach, there's water, there's sand, there's a boat, there's parasols, there's trees. And later, if you want to say, show me pictures of parasols, it's going to find that picture and show it to you, along with all the other pictures of parasols you might have in your photos. Converting voice to text, full machine learning, where we actually asked humans to read text aloud, right? And we're therefore creating the training set that way. You've all heard of AlphaGo. AlphaGo is actually a little bit of an exception. The first version was taught using examples, so using human games to learn from. The most recent version learned how to play the game against itself. That's another step in machine learning achievement. But this was a game that was widely believed to be very artistic, very creative, and very hard to codify a set of rules on how to play the game. Actually, if you talk to any kind of Go player, the kind of terms they use to describe the game is stuff like taste, thickness, influence, things that are very hard to define, right? And we managed to teach those IDs to a computer. And now we have a system that can beat the strongest players on the planet. Okay, very briefly, we believe machine learning is a fundamentally important technology. We believe that no one company should be the master and owner of that technology, that this technology should be accessible to all, and therefore Google places a huge emphasis on sharing what we do in the space. We share our tools. TensorFlow is the crown jewel at Google. It's the main system that we use for doing machine learning. We have open sourced it, so anyone can use it, download it, and put it to work themselves. Everything we publish, by the way, is also, everything we do in research is published. We share data sets as well, so if you want to train your own machine system, you can use the data sets that Google produces. And I would like to show you some example of people who are actually doing this, where there's a farmer that has basically put little devices on his cows that record a whole bunch of things about the cow. He sends his data to Google Cloud. We apply machine learning to it, and we can tell if the cow is healthy or sick, basically. Here's another example of this Japanese family basically produces cucumbers, and that lady was the mother of the engineer. He spent about like 7 to 8 hours a day sorting cucumbers by hand, the good ones, the big ones, the small ones, into different bins. And basically his son, using IoT-type device in a cheap camera and Google machine learning in the cloud, built a system that automatically sorts the cucumber. And again, the system was taught by looking at what the lady does by hand. Another example of applying machine learning, we've basically given the control of our data centers, energy consumption system to a machine learning system. It observed the way we do it by hand for about 6 months, and then we let it run the data center. We saved 40% of energy consumption in the data center using this. Another example, we taught the computer how to recognize diabetes from pictures of retina. Or currently, if you give a computer an image of a breast, a human breast, it can spot cancer with much better accuracy than the best specialist on the planet. Here's another thing you can do with Google Cloud Machine Learning, which is basically upload images and have the cloud basically annotate it and return you the annotation, so you know what's going on in any kind of picture, and you can use it to build product on top of. The last thing I want to mention is machine learning has made forays into art, right? You can shoot a video of yourself handwriting and have a machine learning system imitate your handwriting, right? So you can essentially have a machine learn your own style. Yeah, I mentioned this, we're sharing our tools and we're making machine learning accessible to everyone, and including funding research in academia. Okay, that's the end of my presentation. Thank you very much for having me. And I hope you will pay attention to machine learning, because it's going to be a really transformative and revolutionary technology in the years to come. Thank you very much.